record button once we... Okay, the red light is on. We are now officially recording this meeting.
Excellent.
Cool. So today we have a presentation from Arnaud. I think I saw him on the call. He is going to talk to us about self-sovereign identity, which was a question on all of our minds, maybe a few of our minds. So Arnaud, maybe introduce yourself quickly. I don't know if you've attended one of these.
No, I have not, but it's okay.
Well, welcome.
Should I go ahead?
Yeah, go for it.
Can you spell out your name? Because I want to make sure that you're in the minutes here.
So my name, well, let me show you my slides and you'll get it from the slide. It's Arnaud Lehors. It's 2 words, L-E space H-O-R-S. Space. I know it's hard for Americans to accept that last names can have more than 1 word, but it's okay. I have a whole blog post on my name. It's very interesting. Anyway, well, thank you for having me. So I'll get started by introducing myself. So I'm Arnaud Lehors. I'm from IBM. I'm part of the Open Technology Group in IBM. I'm an open source, open standard specialist, which means that I've been working primarily focusing on standards and open source for most of my career. And I'm part of a group within IBM that basically helps the different business group develop an open technology strategy and execute on it. So over the years, I've worked in different technology areas. For the last 5 years, I've been primarily focusing on Hyperledger. I'm also the main rep for IBM at Directory-C, where I have a long history. I used to be at Directory-C before I joined IBM, although that's 21 years ago now. So I was asked to give you a presentation on Hyperledger, on self-sovereign identity, I should say. And the reason I'm here is because, as I was saying, I've been primarily focusing on Hyperledger for the last 5 years. My main area, so Hyperledger is a collaborative project hosted by the Linux Foundation, which aims at promoting open source development of blockchain technology for the enterprise. We actually have many different projects that are not always related to one another, except for that common goal of being open source based and blockchain oriented for the enterprise. And so I am actually a member of the technical steering committee, which oversees all the different projects and tries to manage the different projects. And I'm currently serving as the chair of the technical steering committee. And so as part of my role, I'm aware of all the different projects, at least to some degree. And as a matter of fact, self-sovereign identity has been a topic that I've had a personal interest in, because I think it's a very promising technology that is bound to have a major impact in the way we live. And so I have given many presentations on this. For full disclaimer, I am not an expert, because this is not what I do on a daily basis. I am not an expert in security or identity. Of course, I'm a computer, software engineer, and I've been doing that for quite a few years. So I am not immune to any of those topics. I have general knowledge. But I can give you a general introduction on what self-sovereign identity is, how it relates to blockchain, and what's going on, what the status is in terms of the development of the technology, because it's a fast-moving space. But of course, when it comes to standards, some of it is standards related, some of it is open source related, and I'll give you a little bit of insight of what this is. And so hopefully, at least at the end of my presentation, you get a sense of what we're talking about if you hear about self-sovereign identity. So can I share my presentation? I have some slides. For now, it tells me
are
that
those
Danny
slides
is...
publicly available somehow?
Yeah, so you should be able to
I
take over the
definitely can
presentation.
make them available. They are not right now, but
Okay. Thank you.
yeah, I'll be
Yeah,
happy to
maybe you'll talk
share
about this in
them.
the slides, but is what you're working on, is it tied to any of the Decentralized Identity Foundation work, or is that a separate effort?
No, it's not. It's separate.
Okay.
So does Dan have to give up? Or can I just still? Oh, there you go. I'll share
I
my
think you can just
screen.
take over.
Um, I haven't done this because I haven't used this app, so now it's going to ask me to give the right to do that. Hold on, guys. Sorry. Okay, Sovrin's going to work now. Eek. Guess I'm not being very lucky because I use this is a Google thing and I use Firefox and I've never used this app before, so it's telling me, oh no, you can't do this. You don't have permission.
Yeah, it became a little friendlier. I'm running Firefox nightly, and I noticed it improved, but yeah, it's tricky.
I'm sorry, I'm trying. What does you want
Take
me
your
to
time.
share? No, this is annoying. I tried to launch the application before and it was fine, but okay. But I didn't share and now it's telling me I can't share.
I found that it's easier if you share the whole desktop and then just put this thing.
Oh, that's what I'm trying to do. Just to be clear, I am sharing the whole desktop, but my screen. You guys don't see my screen, do you?
Not
No.
yet.
That makes you
Just
feel
send
better.
a-
We have. Oh, go ahead.
It keeps telling me that I don't have the right to do that. So
If you can drop a link to the presentation and I could share it and you could talk.
Trying to open a link that leads me nowhere. What do you want to do? Screen recording. Firefox, maybe that will do. Hold on. Oh, I didn't want to stop Firefox now. I apologize.
Arnon has left the meeting.
I've seen that happen, and then it starts working. So fingers crossed.
Well, our last presentation, our own Googler couldn't figure out how to share. I don't know what he was doing. He was on a Linux laptop and then trying to share in a Google Office from his phone, or I don't even know. But
Yeah, it's death, taxes, and bad video conferencing software, right? We'll never get over this.
Dan, do you want to jump into something else while we wait, or I want to give Arnott a few more minutes?
That'll be the fastest way to make it start working. Yeah, let's try that. I'll start sharing again. Yeah, so we had a couple topics on here for today. We'll jump back to Arnaud's once he comes back. The next one was, now I have to switch which tab I'm sharing immediately. Is to talk through the threat models doc again. I think we made some pretty good progress on it, and Gavin actually made this awesome diagram here. So we could discuss as a way to think through some of the different, it's not quite a threat model, but it's like a flow chart where different threat models can happen.
Arnon, sorry, Dan. Arnon, you're muted. We just jumped ahead. If you can get it to share, we can go back.
Yeah, so it made me restart my browser. So if you want to carry on and I present after, hopefully it works now, but I can try.
Let's give it a try. I said the fastest way to get it to work was for me to move on to another topic, so it seems like that worked out.
Let's see.
Oh,
Yeah, it's
I
going
see
to work.
something.
There we go.
Yay!
Yeah.
All right,
Right,
thanks.
you see my first screen, right?
Yes. Thank you.
Beautiful. See, everything is possible. It just takes a bit of effort sometimes. All right, so let's get going. So without further ado, I'll just introduce general concept when it comes to identity, how self-sovereign identity is positioned towards other ways, right? If you look at the history of how identity has been managed, first we had systems that were fully centralized, where you just basically log on to a system and that's it. And then we had systems that are more federated. It's like, using Facebook or Google, your Gmail account to log on to some other system with with the pros and cons of doing this. Very user-friendly in terms of, it makes it much easier, but you don't really control what's going on, who knows what. So then there are things that are more user-centric. So things like OpenID and, so the advantage is the user is more in control of their identity. There's still a problem in terms of portability. It's not universally recognized, and you don't control your ID itself. You have better control over who gets to see your ID and what they do with it, but you still don't control your ID. If you have an OpenID, you depend on OpenID. Self-sovereign identity is trying to get us to the next step where the user is in full control of their identity, and it's universally recognized. At least that's the hope. Obviously, it's not true today, but you'll see there are actually, it can bridges to existing systems too. And so, and the user is in full control of their identity and who gets to see what in terms of their identity. When I talk about identity in this context, it's important to realize that we're not talking about just simple credentials like user ID, password. We are talking about identity in general. This is anything that pertains to a person. So if you think about it in your day-to-day life, you accumulate all sorts of information related that basically pertains to your identity and together form your identity, right? It's of course your identity in terms of like what your government knows you as and recognize as your identity, but it's also things like if you have a driver's license, if you have a university diploma, if you work for a company. All these different bits of information really belong to your identity and form your identity as a whole, right? If you have a credit card in your wallet, it's a form of identity that recognize you have a form of payment from a certain bank, and so on, right? So this is what we're talking about, and when you think about it today, all these identities or pieces of your identity pretty much are under the control of other entities, none of which is you. So, you don't control your national ID, obviously, your government does. Your driver's license is the DMV who owns it, basically, or, whether you can drive or not, and so on, right? And so this is really what we're trying to touch on is, can we move to a system where all this information that should be under your control effectively becomes under your control? So we have this concept of verifiable credentials. So this is, I'll take you through a very simple scenario and you'll see it's very simple. It's easy to grasp. So we have a person here who goes to university and to study to become a doctor, at the end of which the university is going to issue a verifiable credential that states that the person is indeed a doctor because they've received the diploma from that university, right? And so effectively, this is done in a form that's electronic, obviously, that will be stored by the user in some form of digital wallet, right? And it has a bunch of information. I'll go more into the detail of what the information contains, but essentially it's going to contain information about what this represents, who issued it, if there is an issuance date, for instance, that kind of information. At the same time, what the university is going to do is going to store in some storage, typically a blockchain. This is how you get to the self-sovereign identity, part. They're going to store basically the material that is necessary for a third party to verify the claims, the credentials that was being issued to the user. And so this is stored in a repository that is meant to be accessible by anybody who needs to be able to verify the credentials that was issued to the user. Now, that person wants to go look for a job with a new diploma. She goes apply for a job to an hospital, and the hospital says, well, are you qualified for the job? The person is going to say, yeah, I'm a doctor. Here's the credentials. This is basically based on the verifiable credentials that was issued by the university. In it, there is embedded an identifier that's going to point to the piece of information that was stored by the university on the blockchain. With that, the hospital is going to be able to verify the credential. This, obviously calls into using some cryptographic material. They use cryptographic method to verify that the claim is indeed valid, right? What's interesting is that the verification does not involve the issuer, right? So the hospital can do that without the university being involved, even though the university obviously was the issuer. That has many advantages, right? This is a blind verification. The university does not have to be involved. So even if the university was to go away at some point, you could still verify the credentials the user has. And the university cannot just take it away, either. So this model obviously scales in many different ways. And this is what I just explained to you is enough to basically, this is the foundational block for the whole system. Now you can extend that to anything you want. So if the person wants to apply to many different hospitals, the same mechanism is going to apply. By the way, that means the university does not get into this at all. There's no scalability issue from the university point of view, just because they once they have issued the credential and stored the cryptographic material necessary to be able to verify it on the chain, they are not involved anymore. And by the way, there's a privacy aspect to this, right? So if you take another scenario, which is, in the US, we have a limit for drinking, which is 21. If you imagine instead of university is a bar, the hospital is the bar, the university is DMV, they issue your ID, that says you're over 21. Every bar you go in, they're going to check that you're over 21 before they serve you a drink. The DMV does not have to know you've been bar hopping the whole night, right? So each bar is going to make the verification, and the DMV is not involved in any of this. And obviously, this model, scales to any number of issuers. So I just talked about a university. I talked about the DMV. You can quickly imagine how this scales to many other things. Once the person has a job, the next thing they're going to do is say, well, I can go to a bank and maybe ask for a loan to buy a house or a car or something. And the hospital, who is the employer, can issue a credential that says, yes, this person is actually working for us. They're an employee. That credential can contain many different kind of information, including, certain income, so that you would qualify for a certain amount of loan, right? And so you can see how this system keeps on going. And as you move forward into your life, you accumulate more and more credentials, all of which remain under your control. And that's a very important aspect. So this model obviously scales in many different ways, and you can combine different credentials. So typically, if you're going to exchange a credential, it's very likely to refer to more than one piece of your identity. So, very fundamentally, typically you're going to say, hey, I have a driver's license. Well, driver's license is a bad example. In the US, it's the same as your ID typically. But, if you say, I'm an employee, or I have a university diploma, and here's my ID, the university diploma is likely to refer to the ID. And then the question is, well, how do I trust this is your ID? And so you can actually combine those claims. So you could have a verifiable credentials that has been issued by the DMV or the government in general, right? That defines your national identity. And then you have a diploma, and you can combine those two so that the verifier, the party that wants to verify, can verify the different facets of the information that you're exchanging with them. This is really the crux of the system. There's not much more than that. And I'll give you a little bit more insight as to what kind of information we're dealing with. But this is the general model, this basic triangle. Now, there are other aspects that are important. We have this mechanism of supporting selective disclosure. So going back to the example of the bar, for instance, the naive, when you think about it, every time you enter a bar and they ask you for your ID to verify you're over 21, they actually have access to a lot more information than they really need, because it's going to give them your name, your address, all sorts of information. It's even going to give them your birth date, even though what they really need is make sure you're over 21. What date exactly is your birth date, that is not relevant to the transaction. So what we're talking about here is a mechanism that will allow you, as the user, in control of your credentials, is to actually choose what you disclose to the verifiers. And that's a very important improvement in terms of privacy, because if you want to prove something, you don't have to disclose everything. And we can do that in a way where, independently of there's a matter of how it's implemented when it comes to verifiable credentials that are issued by the issuer. But it can be fine-grained enough that you can really split apart the pieces of information and disclose only really what you want and what's relevant to the transaction at hand.
Quick question for Arnaud.
Sure.
Yeah.
Please.
Go back.
Oh, sorry. Which one? This one?
Yeah, you're right. You talked about showing only what you want to disclose, but does that require that the issuer issue it in part so that each part is signed separately, or is this something that's completely under control under the individual? Because if you depend on the issuer to separately sign all these different pieces, they may choose, that's not convenient, and then you can't take advantage of that.
Yes, that is correct. In fact, this is why I say it depends on how it's implemented. But ideally, you want the issuers to issue things in a very small piecemeal kind of way, so that you can indeed more easily use them independently of one another. That's correct.
But that's also prone to abuse then, no? Could somebody just selectively show information that's beneficial to them? Say, for example, that you have a bunch of arrest warrants or something like this.
Yeah, I understand what you mean, and it's a totally good question, and you know, it's always the same. It's like with more power comes responsibility, right? It comes down to this. This is why the issuer may not want to separate some aspects of it, right? They have to be be cognizant of the fact that, well, can that piece alone be misused? You know, be misrepresenting, and you know, for instance, the example is like you also want to know who is the issuer, right? At the end of the day, there's always the prime of the chain of trust. Can you trust the issuer? Who is the issuer? How do you know who the issuer is? Because, you know, you tell me, hey, are you a doctor? I send you a credential that says I'm a doctor. You go to the chain, you find some keys there, you know, some cryptographic material, you check it, hey, it works. You know, the proof tells, yeah, this is a valid credential. But wait, who issued it? If it's my mom, you're not much better off, right? You need to make sure you understand who the actual issuer is. And so there are different aspects like this that still are very important to get right, because indeed, otherwise you can open the door to abuses.
Yeah, you so far when you said identity always talked about individual persons. Do the systems that you're talking about also support identity of organizations and projects, or is
Absolutely.
that okay?
Yes, organizations and even things. It's anything that you want to, because at the end of the day, and if we move a bit in a couple of slides, I have what we
Okay.
talk about DIDs, decentralized identity identifiers, and you'll see that it's just a URL, and you can create them for whatever you want. Then it's a matter of, you know, who has control over the this identity, and what you decide it represents.
Okay, so governments and so on could themselves have IDs, identities that
Absolutely.
would be okay. Thank you.
Absolutely.
Okay, go on.
So this is just a little bit more on the kind of things we do with those verifiable credentials, right? So as I said, it allows real-time verification, and with that, the direct connection to the issuer. This was the blind verification that I talked about, right? It's, however, revocable. So there are mechanisms so that, for instance, you know, back to the DMV, it's important that the DMV can say, sorry, that license is expired, right? Or you're a drunk driver and we suspended the license. They want to be able to revoke your license. So there are mechanisms, and depending on the way the storage, different systems handle this differently, but there's a way to say, you know, when you verify, you can also ask, has this been revoked? And you'll be able to figure it out. I talked about, you know, how you can combine different things. So this is an example, you know, where they have a credit score, a mortgage balance, and income, and you can have, imagine you're pulling from different issuers, you know, different credentials, and combining them to present it to the verifier. We also have, and that's a bit more interesting, and it doesn't work for everything, but you know, it refers to knowledge, zero knowledge proof. I don't know if you guys are familiar with this. I imagine everybody has heard of it. And so this is the ability to verify a statement without actually, you know, seeing it. And so in this case, we can, even though the issuer may only have given you a credential for a specific birth date, you can still do the verifications of whether you're over a certain age without disclosing the actual birth date. And this zero knowledge proof has been around for a long time. I'm not a crypto expert by any means, but you know, the difference is that we have now achieved, thanks to the advance in technology, you know, both hardware and software, we are able to do that in fast enough that it becomes usable. You know, I asked one of my colleagues who is a renowned expert in the field, it's like, I said, how long does it take? He said sub-second. And that was that was the answer. That meant we can actually use that on a practical basis. And the other aspect, as I said earlier, there's privacy involved is very important, right? And there are a lot of systems around today that fail in this regard because there is correlation. If you do a transaction in one place, then people can kind of track you and find other things and correlate other things. So here we can do all these things, so to verify that somebody is over 21, for instance, as I was saying, at the entrance of a bar, you wouldn't have to disclose your name. This transaction can be anonymous. All they need to know is that you're over 21. And again, anti-correlation, it means, you can go to many different bars and they wouldn't know you've been doing this all over the town the same night. And selective disclosure, it means, again, the user is in control. So of course, you can't control what the third party, the verifier, is going to ask and want to verify, right? But you can choose. They will have to say, hey, can you give me that information? Can you prove me this or not? And then the user is in control of saying, yes, I'm willing to disclose this. So like, you want to apply for a loan at the bank, it's common that the bank is going to ask you to prove that you have enough income to back this up. And so it's up to you to decide whether you agree or not, but the system allows you to effectively decide that. So there are certain aspects that I want to highlight, and I don't want to take too much of your time, guys, but so one important aspect is, in the end, so the ledger, that's the blockchain, right, that I've been referring to. There is always the question, okay, but what's written there? And especially, with GDPR in Europe, but in general, this is kind of, all over the place now. People are concerned with personally identifiable information. Where does it get stored? And obviously, one of the key aspects of the self-sovereign identity model is to avoid putting any personal information on the chain or on the ledger, the chain. And this is a very important aspect because people always are confused with this. It seems like, oh, but I'm going to have to store keys or something to verify the information. But if you think about it, in this case, it's the issuers that are putting keys and information on the chain. They are putting enough information that a verifier can verify the credentials, that are held by the user, but and again, user entity, right, whoever that is, and the entity that is issuer typically is an organization. It's like I said, the DMV, your employer. None of these are persons, and therefore their data is not personal information, right? And so what we store, again, and I'll get a little bit more into this, but basically, there's this notion of decentralized identifier that points to a certain record on the ledger, the blockchain, and then when you pull this, you'll get a document that has different pieces of information. It has the keys to cryptographically verify the credentials that have been signed. Is that actually a valid credential? But it also has like service endpoints. There's like literally addresses of system that the verifier will go to connect to do some transaction, such as enabling zero-knowledge proof verification and so on. There can also be information about the schema because at the end of the day, those credentials, they hold a certain amount of data that is structured, and you want to know what is that data. Am I actually looking at a driver's license or pilot license, or is that like a cooking, certificate that you went to a class on Saturday? You need to actually know the nature of the information that is signed, the credential. What is that credential about? And so that actually calls on to this notion of schema that is known somehow. You need to be able to verify not only that the information is valid, but that the information is what you want in the first place, right? So this is what the deed looks like. it's essentially a URL. Okay, there's a new scheme called did, and then there's a method, and then there's a pod that's like specific to the method. So there are different systems that are defined. There's a registry, so it's that part, and I'll share my my own doubts about the system, or at least acknowledgement of the limit of this whole endeavor, is that there is a registry which is today, so it's basically a GitHub document on the W3C GitHub organization, and if you want to register a new method, you have to basically post a new document attached to that registry on the W3C GitHub website, and you say, okay, this is the method I want to register, and then you're going to use some resolver in your system to basically say, oh, I have a did, it's this method, I need to apply this mechanism, and it's up to you how you actually implement this. And so typically the method refers to, it's an identifier of some blockchain network. So there is one like for Bitcoin, there is one for Ethereum. This is refers to Sovrin, which is another network, and there's a whole bunch of them, right? And nothing stops you from creating your own, for that matter. And then the piece behind it basically is how you go beyond that. Typically, it's the address of a record on the blockchain network, which will allow you to go find that record on the ledger, and then you pull this, you end up with what we call a did document, which is this document that will describe, what you can do with that identifier. And again, it has like the public keys, the service endpoints, that kind of information. But so there's a beauty in this, which is it's very open-ended. And in fact, there are people who said, well, the method could be HTTP, right? Or HTTPS. Therefore, I can even piggyback on top of HTTP, and then the method-specific identifier is just the domain and the URL, typical URL, the HTTP URL kind of thing. Of course, the problem is you're putting back centralization into this, but it does provide for a bridge, right? So you could have a did OpenID and then, an OpenID URL after that too. This is really open-ended. The whole premise, though, and I'm being open on this, is that how is that more decentralized? And people have said, why isn't that just a URL, a web URL? But then you're like back to web ID type of thing, open ID type of thing. And the difference is if you use a blockchain network, you do not have a single point of centralization of control. And so that means those deeds, cannot be pulled off from your control by a single party. That's the only real big difference. But of course, it can be a crucial difference. And, you have to, if you believe this is important, because URLs depend on the domain names, which depends on the DNS, which you don't control, and your ISP is going to have a say in it, the DNS resolver, and the whole DNS tree. Obviously, the domain names are not completely under your control, so they can pull it off, and you lose your domain name, you lose all your identities. One thing that's important and this brings us back to the question that was asked earlier, is those deeds are actually pretty cheap to create, right? And so nothing prevents you from creating deeds for anything you want and as many deeds as you want. And part of increasing privacy comes in this ability to create deeds as much as you want. So if you want to avoid correlation between different operations you make, you can issue new deeds for about every transaction you want, if you like, right? And so that makes it easier to kind of avoid correlations throughout the history of your using your identity. So just to finish, and if there are questions, I'm happy to take them as much as I can answer them. But I wanted to give you an idea of what's going on in the field there. There are two fronts for the development of self-sovereign identity. There are some open standards being developed. And so there are two that I mostly talked about. There's the DID that I just gave you an insight of. So that's a Directory working group. They're developing a specification that defines the DID syntax, but also the DID document, what it contains, what you can do with it, the format, etc. There is the verifiable claims. That's the actual document, that you're going to be able to get from the issuer and then exchange with the verifier. And then there is another piece. It's actually not in the work yet, but it's DKMS, which is a decentralized key management system. And it's expected to happen eventually to go at OASIS, although they've been saying that for a couple of years, and I haven't seen sign of it happening yet. So I don't know exactly why, but I think it's important to realize there's many facets to this. There's also the whole, orchestration of the protocol between the different parties, right? How do you actually orchestrate this, connecting to an issuer, they issue the credentials, you store it in a digital wallet, then you go to an organization, they ask you for certain credentials, you have to exchange them so they can to prove them. And and I talked about selective disclosure. It's like, okay, but at the end of the day, how does that play, right? You have to orchestrate this exchange of information. So there's a lot of moving pieces still not completely sorted out that will come into play over time. And then the other facet is the open source effort. So there are several of them. There is the Decentralized Identity Foundation. Is basically they actually have an implementation of a resolver. So this is mostly what they do, and they do a bunch of different tools. But the main pieces actually are in Hyperledger. There are 3 projects that relate to this. The first one is Indy. That's and to be honest, the other 2 were basically spun off from Indy. So when we started several years ago with Hyperledger Indy, it contained a whole solution stack for the self-sovereign identity problem. So there is a ledger where you can store the keys, and all the stuff that I talked about. And there's the digital wallet. So the digital wallet was spawned off. It's Hyperledger Aries, and the reason for which it was spawned off Indy is because it was made to be independent from Indy, and thanks to the standardization effort, they can actually make Aries a digital wallet that works independently of the actual ledger that you use. And so it was important to separate it from Indy. And then URSA is actually a library for cryptography. So they pulled out of Hyperledger Indy /Aries all the cryptographic code and put it into a library so that people could reuse it. And it's now being used broadly, both within Hyperledger, different projects use it, but even beyond Hyperledger. And so is Aries. So I mentioned there are different, DID methods, and there are different projects that do self-sovereign identity kind of things. And Aries is actually being used by people who use Ethereum and Bitcoin and other things that have nothing to do with Hyperledger, but they still use the digital wallet. So that's pretty much my presentation. I try to keep it short and to the main salient point to give you a sense of what we're talking about. If you want to know more, I highly recommend reading this paper that was published a few years ago, but is still very much relevant and gives you a really nice overview of what this whole thing is about. And so I give you a link there. You could look it up, Sovrin white paper. and there's a library section on their website. So Sovrin is is basically an instantiation of Hyperledger Indy, and there's a public network. So it's interesting, by the way, because you may have heard that in the blockchain space, there's two main categories: permissioned and permissionless. And there is also public and private, and people tend to confuse the two, thinking this is the same. But this is an example where, Sovrin is a public permissioned network because only some entities have write access, but on the other end, anybody can read into the network. And this is very important because that means there's an onboarding process for issuers. So not everybody can, store information on the ledger. On the other hand, any issuer, that means anybody literally, can go and verify, get the keys so they can verify a credential. And if you think about it, it's not very different from what's happening with the DNS. Not everybody can write to the DNS, right? Record a new domain name. On the other hand, anybody can do an NS lookup.
Can you go back to slide 13 for a moment?
Like 13,
right. Yeah, for the method-specific identifier, I assume that's a public key essentially.
Public key, not in a cryptographic way, right?
I would assume it's probably
just a string
lookup thing.
It's literally just a string.
Okay.
Oops, sorry.
So you're then going to need to prove that you're the owner. Probably is the wrong term, but that you are represented by that method-specific identifier.
Well, no. So you have a DID, and it points to a method, and then the resolver, right? You're going to say, oh, this is a Sovrin identifier. I'm going to go to the Sovrin network to try to resolve it. This method-specific identifier better, and there's a documentation, there's a spec associated with the Sov keywords that tells you what you can do with this and what kind of document you're going to get back and what you can do with it. So there's no trust issue at that level. I mean, you can decide at the application level, you decide what identifier or what method you support, right? But if it's
This
solved,
is just a name system, basically.
Sorry.
Okay. Yeah, it's not the identifier of an individual. It's the identifier of a method.
Yes, that's correct. And so that refers typically to a public network or blockchain network, right? So then you have to figure out how you connect to that network. You go to some node and then you talk to the Sovrin network. It's hard for somebody to pretend they are a Sovrin network. You're in full control of how you access the Sovrin network, and so you can trust that.
I had a couple of questions. I don't know if we're done with this one. I'll take it. Yes. So one of them is like the usual blockchain keys under bird path type of thing. Of what happens if I lose my keys to my identity? There was a talk about having revocation, which is basically, and it was like the hint was, oh well, an institution can revoke their authorization for me to have a diploma, but what happens if I lose my keys and I want to keep my diploma?
Yes, so I'll be honest with you, there is no perfect solution to this problem of lost keys, but it's a known problem and it's something that is being worked on. There are different solutions already being proposed to solve this. The most popular one seems to be that, you're going to depend on, there's basically a mechanism to do key recovery. And there are different ways you can go at it, but I'll give you a hint of, the things that I've been told about is, for instance, a method that they're talking about is you actually take your key, you split it in several chunks, and you share that with several people or systems that store that part, and each and every one of them can't do anything. They don't even know who they are, who else has the other pieces. But if you need to, you can go back to them, say, give me all the pieces, and then you can put together back your key. But they are, in a way, they're trying to mimic some of the things you can do today in real life, right? There are ways for you to recover. It always depends on relying on some other, trust source that will be able to basically, assert and in a way that has enough authority, obviously, to that you're the person you claim to be.
So like a secret sharing based exceptional access scheme would be like a way to describe it. And another follow-up that I had on the earlier one, question that I had regarding selective disclosure, it seems to me that to avoid this potential for abuse, there should be some sort of pre-agreement on the certifier about what is this certification going to be used about. So in a sense, if I am a university or say the DMV, and I know that this is going to be used for checking people's ages and probably if they're allowed to drive, I would have to pretty much pre-print the certificate saying, oh, well, this is going to be used for checking ages, and this is going to be used to check whether they're allowed to drive. And I know that you can use CSNARKs to check this without leaking the information. But what comes to mind is the issue in the United States with like the social security number, in which basically it was created for one thing. It ended up being this universal identifier that was eventually leaked to third parties that have horrible operational security, and now everybody's suffering because of it.
Yeah. But so I mean, this is going to depend entirely on how people end up disclosing that information, right? And whether they accept that or not. It's true that today, I mean, as a user, we often don't have the really much choice, right? If they ask you for your social security, you're like, okay, I don't know why I have to give you that. And that problem remains. I don't think that solves this problem.
Right. Yeah. So that is what I am trying to see if there's a way forward to solve this, because it is a little strange to me that we have this ability to issue a bunch of different certificates to say, well, I am a university, I am certifying you as a doctor and as a student, probably top 5% of the class if you're applying to graduate school. And I'm giving you all of this information that you can use to essentially disclose selectively to different people. But at the same time, there's the potential for abuse. So then you say oh, I am going to create the certifications within certain constraints, but then I need to, me as a certifier, consider what can a selectively disclosing party do with this. But then I have absolutely no idea what can happen.
Yeah. No, I understand. And again, I mean, there's a social component to that, right? I mean, technically, you control, but then from a social point of view, whether you can enact that control or not, I don't know. The future will tell. Because, of course, if you apply for a loan, for instance, and they say, oh, we need this and this information, theoretically, you can say, sorry, I'm not giving you that information. It's irrelevant. I don't know why I should. What the hope is, if at least the technology allows you to select and selectively disclose information, there should be some competition, and there are others who are going to say, no, we don't need that information. We'll give you a loan without asking you that. Whether you believe in free market, I don't know. That's a different story. Where the competition always works to the advantage of users.
Cool. I don't want to cut this off, but we have a couple more topics just to go through quickly. And
I'm sorry, I've taken too much time. But
no problems. Yeah, really interesting discussion and good questions there. In 4 minutes, I guess, Gavin could walk us through that diagram and maybe talk through next steps there in the threat models doc. I really like the way that this diagram frames the overall scope of the problem and everything that we were discussing. So let me pull that up, and then you can talk, Gavin.
Yeah, well, it's coming up. I guess my thought process was just, we've kind of been all over the place on scope, and really, it seemed like the core question was the areas where identity of entities that want to do something matter. So I kind of just took a stab at writing down all the places in a software supply chain where that could matter. So there's basically a box for each place where identity might make a difference. I sort of took a stab at. I think there's a difference between trusted and privileged, right? There's things that you may trust to do something because you know something versus something that's totally unknown, but it's not really privileged, right? I like a code reviewer, I trust to review code and I take their feedback with some weight, but they're not privileged to, merge that code or do anything else with it. And then I also kind of tried to talk about the elements that could be used to establish identity at those stages and the things that could happen if there's a failure in identifying that entity. So that was kind of the thought process. I'm sure there's probably others, so feel free to mark it up. It's just a Google drawing, so you should be able to access it if you click on it in the document. I'll grant you access.
Awesome. So we were trying to use, I guess, some of these top-level bullets to gauge interest and see which areas people are most interested in focusing in. I think your diagram is probably a better organization than we had here. If I try to turn these into bullets and then have people kind of stick their names next to the ones that they're interested in to kind of upvote, does that make sense?
Yeah, and I think my concern with the list was that it's not that they're not all real problems, they're just not necessarily tied to, right? The things that could happen if identity is compromised.
Right.
There's other ways those things could happen as well. So I think the
cool
establishment of identity seemed to be the focus of this group. So I tried to pull it back there.
Okay, yeah, so if I take these and just turn this into text to make it easier for people to put their names next to, and then reference the diagram up above, I think that's probably good, just to gauge where people want to start focusing in here, because, yeah, this is a huge space. I can do that and send it out, and we can make progress on that asynchronously. Sound good?
Sounds good. And some of these, I mean, there's definitely going to need to be some discussion about scope. For example, I put in the issue about repos being subverted. I mean, that doesn't automatically mean that somebody's identity is subverted, but if your goal is to connect identity with particular commits or releases, then that's an important problem to acknowledge.
Yeah, I opened another issue too. I just wanted to call attention to. I'm not going to try to share the screen, but it's in the repo where I wanted to try to walk backwards through this flowchart Gavin made for an actual project that I'm pretty familiar with. So I took Kubernetes, and I've started with the artifacts that get released with the Kubernetes release, and I'm trying to kind of follow these arrows backwards and see if I can get all the way back to the code and PRs that were used, to then figure out all of the different identity things that you have to trust when you're taking one of these, release binaries, and it's challenging. I thought that might be a fun thought exercise to publish, just all the different people you have and systems you have to trust when you take a complicated project like this and try to use it. So if that sounds interesting, take a look there. I can definitely use some help trying to figure everything out. Anything else, Kim, or anybody else want to cover before we end this?
Just one last thing. The meeting on the 28th, I'm going to move it to 3 p.m. Pacific time. We have a presenter, another Googler, presenting on Git signing. He's based in Sydney, so trying to be accommodating because he would rather not present to us at 2 a.m. So I will try to figure out how to send out the one-off meeting invite for that, and please come if you're interested in learning a bit more about Git signing.
Okay, can you repeat that time again so I can put it in for now?
Yeah, we're aiming for 3 p.m. Pacific time on October 28th.
And he'll be talking about a bunch of ongoing work to make it possible to sign Git commits with SSH keys instead of GPG keys. Well, I guess in addition to. It's pretty interesting. Okay. Cool. All right. Thanks for joining us today, and thanks for the excellent presentation.
Yeah, thank you. That was great.
Yeah. Thank you.
All right. Have a good day, everyone.
Thank you.